Hello, my name is Exner.
And I'm Lucas Boyd.
And I'm Trevor Klippen.
And our capstone project has been working with Danfoss, helping out with their H1B rotating kit. Our objectives for this project were to initially analyze demand trends and to determine if the current Danfoss production system is able to meet the demand requirements over the next 5 years. Then, we plan to outline a method to fulfill this demand if needed with an IRR of 40% over the same time period. We also aim to do all of this while minimizing the amount of interruptions to the overall production plan of the Danfoss system. Looking into the H1B components, as you can see through our chart at the bottom here, this is a quarterly breakdown of demand requirements and production capacity of Danfoss's current abilities. And within the next year alone, the rotating groups are going to be not able to meet demand requirements, let alone for the next 5 years. Within the rotating group, the sink joint, shaft machining, and pistons all failed to meet the required production capacity.
So now that we understood our capacity over the next 5 years based on compared to demand, we were interested in seeing whether overtime would be sufficient to fulfill demand. And we can see here, based on 15, 18, or 21 shift models per week, that demand cannot be met even using a 21 shift model over the next 5 years. So because of this, we knew we needed to increase capacity, and through research, we determined that Ames would be the best location for that new production line. So given this, we created a criteria matrix based on prioritization criteria developed with Danfoss, and we evaluated 4 different layouts that we determined were good options. Based on this, we ended up with a final best layout option in the DCP pack area, and this was determined to be the best just generally based on availability timeline and the available space after installation, as well as reducing product travel distances.
With this added production, our group will plan on running an 18-shift model until the final implementation of the DCP pack area, and with that, a $40 million budget is viable over the next 5 years in order to meet the 40% IRR. After talking with the client, however, we determined that it would only be about an $11 million investment, leading to a roughly 60% IRR. Lost revenue before implementation due to missed demand from the reduced capacity would only be about $1.5 million, and overtime costs until final implementation will be about $72,000 to $170,000, depending on the ratios of running traditional overtime or a weekend warrior shift. Weekend warrior shift being more expensive, but having a better impact on employee morale. And overtime costs saved per year after the implementation due to only having to run 15 shifts to meet capacity is going to be between $24,000 to $57,000. Shipping costs will decrease by about 60% per kilogram. A slight carbon footprint increased, however, though, as more land travel is involved, and the long-term financial stability of the company is maintained by meeting the demand of one of their most popular products. Based on these results, our group's recommendations are to add the piston assembly and manufacturing and the final shaft assembly lines to the Ames facility, as the Ames facility specializes in assembly processes, and move the machining steps to Querétaro, Mexico, and ship the components to Ames by land, as the Mexico facility specializes in machining. And for all other areas that have local demands that won't be met by this, continue to do what's currently being done and ship them from Neumünster, Germany. Additionally, we plan to place the piston shaft assembly as indicated in the DCP pack option, since it had the highest score in our matrix with a score of 750 due to various reasons, as well as we plan on running an 18-shift model until the final implementation time of Q4 2026. Our group also recommends that we run a weekend warrior crew, as that would have a significant impact on employee morale. And all of this should be considered that the Danfoss Ames facility is going under a lot of different projects right now that all influence the plant layouts, so making sure that this Danfoss team is communicating with the other Danfoss engineering teams that have projects that also influence the plant.